So, Raul, give Martha a calculator.
Oh.
Okay, roll 5 times again, going backwards. Guys, for this, I cannot have you guys screwing around today. I really can't. It's going to get very ugly very quickly, and you guys are going to get very lost, and it'll be very bad. So, please do not goof around. Do not talk, do not chat. I just need you guys to focus. Okay, Nicholas.
Should we be taking
Not quite yet. So the idea is I have given you this problem in the past, and I said find f of x for all x. So how do you do that? Ryan?
You plug in 2x for each element of x and you find what f of x is.
Perfect. So I say f of 1 equals 2 to the first. F of 2 equals 2 squared. So on and so forth. For an equation like this that we've seen 14 million times now, not so bad. For an equation that's a lot more complex and has a lot more steps, it can be a pain. So the goal is, how do we create a program that can handle this? So when it comes to programming, like Ryan said, we do this to make our lives easier. And programs are basically comprised of 3 parts. An input, a calculation, and an output. So what we're looking at is we need some sort of input, some sort of calculation to happen,
Should we take notes on how to program?
and an output. Yeah, you can maybe, this might be something good to have in your notes. I am never going to ask you guys to write a program on paper. Okay, so on a test or something like that, you will never see that. But the theory behind what's going on is very useful in terms of how do you get these things to do it so you don't have to. I've had plenty of kids who program their calculators to do all sorts of crazy stuff, so they don't have to go through this process. I had this one guy, his name was Christian in high school. He did ridiculous stuff with his calculator.
Christian who?
Smart. Christian Smart.
Makes sense.
Actually, yeah, that is his name. Anyway, he hated math, by the way. Nevertheless, Christian really latched on to this idea of programming because for him, it was a quick little shortcut. He put a lot of work up at the front to do something. He suddenly wrote programs for chemistry, for his math classes, for everything. So he could actually just type in an input, it would spit out whatever he wanted for whatever program he needed. It was phenomenal. I don't expect you guys to do that. We're just going to look at the basics of what this is today. Alright? So for an input, we need a way to say, I want to let x go from 1 to 10, and then to calculate all these things out. Okay? So I need to input x from 1 to 10. Now there's 2 ways to do this. You can type in 1, run it through the program. You can type in 2, run it through the program. But that's still a lot of work on your part. So we create what's called a loop. So our input, we're going to create what's called a for loop. We're going to do a for loop. And what that says is rather than you having to type in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're going to say for x from 1 to 10. In the background of your calculator, when it sees this syntax pop up on it, it understands I'm going to count up, I'm going to start at x, start at 1, and count up all my integers, all the way to 10. Let me stop there.
Are we doing anything yet?
We're going to get there in a second. I want to get the code up on here, and then we're going to put it on the calculator. So, our input is going to be for x from 1 to 10.
That's just for this particular.
Just for this particular program.
Should we
If I were to ask you guys, what is the domain for my program? What is the inputs? What's my domain values for this program? Roll.
0 and 10.
Nope. John?
1 to 10?
1 through 10. Every single number?
Yes.
No.
It's 1.
1.5?
Oh, no, just 1. All whole numbers.
Whole numbers. So our domain,
Integration.
x, is an element of the positive integers. Here's our domain.
Yeah, just from 1 to 10, right?
Just from 1, oh, thank you. Thank you. X is an element of 1 to 10. The square brackets mean inclusive. Means I'm including 1 and I'm including 10.
And then you put positive.
Positive inches. Okay?
Do we have to put the positive integers?
Yeah, because otherwise we could imply that it's 1.2, 1.3, or 1.11. So we need to make sure to talk about only the whole numbers.
I need to know the domain.
Why do we need to know the domain?
Yeah.
Because when we start looking at how we're, well, you'll see in a second. Okay, Ryan.
Why did you have to put positive integers if all the numbers specified are from, like, all positive?
Because I'm asking you to be clear. Your calculator has it in the background, but you can actually change this so it goes up the way it wants. I can add a line of text into this program that says x is going to increase at 0.5. So then I could go 1, 1.5, 2, 2.5. And I can actually break that so the calculator doesn't think just going up by once. Alright. So, we're going to do a calculation. What do you think our calculation is?
F of x equals 2x.
2 to the x. The way we put this in our calculator is we say 2 caret x store in y. 2 caret x store in y.
Is the store button the one right above the
Yep.
on button?
Yep. The output, what do we think what do you guys want to see put out? What do you want the calculator to spit back at you? Nicholas?
The result.
The result. And what is the result here?
Range.
It is a range,
Y.
but it's our y. So we're going to have this display y. We're going to have this thing display y. Okay? Now let's get to the program.
What's it called?
Huh?
What should we call it?
We're going to talk about that. So, if you could, please turn on your calculator. There's a button on your calculator. It says PRGM.
Above 8, like 3x.
Couple above, 3 up above 8. Please hit that. PRGM. And you're going to scroll over to new. You definitely do not have this on your calculator. So scroll over to new and hit enter. First thing you need to do when you get to this program is you need to name it. So we're going to call this thing calc. Nope. See how there's an alpha character already? It's already programmed. It has to put in calc. C-A-L-C. Just calc. Alright? Once you've got that in, please look at me. Claire's still going, John's still going.
Could you name it? Yo.
Yeah, but you generally want to name your program something that means something. Coming from someone who was a dork in middle and high school and named my programs not easy things to remember, it's a real pain later when you have to go back to that program and figure out which one RAR is actually referring to. Is that the quadratic formula? Or is that calculating, I don't know, electrons in some sort of atom? Okay? So it's, name it something that makes sense. So we're going to name it calc. Hit enter. So for our first line, we're going to define this for loop. Now you guys remember what button we pushed to get in here? Program.
I'm confused what the for loop is.
We're about to get there. Okay? So, if you hit the program button again, you're going to notice it looks a little different. So hit program. We now have these conditional statements. If, then, else, and for.
Why do we look for loop?
Just look for for. So we're going to scroll down to for and we're going to hit enter. And we're going to type in x and make sure you choose the variable x, the one that's up with the theta and the t.
Next to the alpha.
Next to alpha.
Judy Rage.
So type in x. Guys, this is where I need you quiet. Barry. Comma, which is right above 7. 1, comma, 10.
Oh.
Do it for parentheses.
Close the parenthesis.
That's the domain.
That's our domain. Okay?
Wait, so do we have to do each one of these for a different equation?
Nope, we'll talk about that.
So can you go in and edit it if you want?
Yes. So, Nicholas,
What about plus I?
what about what?
Plus
No. This is just us spelling out what the domain is. Our actual program's right there. Now, next line down, hit enter. We're going to type in our equation. 2 to the x. And then there's a little store button above arm. It's
That's a stone.
STO.
Oh, and it gives you a little
Where's
arrow.
X?
Where is STO?
Oh, shoot.
Okay,
Why?
stone.
2 to the x, store y. You need to hit alpha, and then you need to find the little green y.
It's 1.
It's above 1. So hit the alpha key, it's below second.
What? It's what? It's
Hit
what?
alpha and then 1.
Oh, so where is that?
So alpha's up in the upper left corner,
Could you do alpha X?
and y is 1.
No.
There you go.
There.
Okay,
No, it's not a variable.
x, that's going to be some, you might be able to, but I would stick with this x, it's a specified variable in the calculator. Okay, hit enter. And we're going to display y. The way you do this again, go to program, go to input output, IO, scroll over, and scroll down to display, disp, hit enter, alpha y, enter.
What?
Okay, now typically in programming, whenever you start a loop or start a process, an if-then statement, while, for, you always need to tell it that you're going to end it. So last time we're going to go to program, scroll over to end, scroll down to end, I'm sorry. Scroll down to end, and hit enter. Okay, second quit. Second mode. Okay. So right next to the second, there we go. So to run this program, we're going to go back to program. Do not hit enter until I say so. So go to program, scroll down to calc wherever it is, and stop there. Right stop.
Too late.
Okay, raise your hand if you're here. Excellent. Now, follow me very carefully. Hit enter. Stop. Does everyone have this on their screen? Program calc.
Yes.
Okay, hit enter.
Oh my goodness.
Okay,
I'm blown.
mind blown. We just wrote a program. So, that's kind of nice, except what happened?
It scrolled down.
It stopped.
It stopped, but more than that, we didn't see what's up here. So we're going to go back in and we're going to add what's called a pause so we can actually see it. So go back into the program.
Oh wait, so it goes down to the bottom
So
line.
program
Yeah.
edit.
So go down to program, scroll over to edit, and go to calc. And be very careful with what I'm about to say because you could delete some stuff. So hit enter. Scroll down to where it says end. Now stop. Nope. Scroll back to the beginning of end. Do you see the cursor right here?
Yeah.
Hit second. DEL. Hit second DEL and stop. Look what happened to the cursor.
It goes like,
Yeah.
Link.
Wait, so
So
why did you do that?
Without.
Second DEL. This is
I got it.
insert. What this does is it keeps you from deleting your program that you've already written. Now we've only got a line here, so it doesn't matter that much. But when you've got 15 hundreds of lines, you want to make sure you don't delete that. So hit enter now, and it's going to insert a command line. Go back up.
Swag.
We're going to type in pause, or not type in pause, I'm sorry, go to program. Scroll down.
Pause.
To pause,
wait,
it's
wait,
8.
how did you enter that command line?
Second, delete.
Down.
I did that.
And then enter.
And then you hit enter.
Yep.
Now go up.
Okay.
Program.
Now
And
second
then you
quit.
can do it by just like
Alright.
pause.
Mr. Morgan, I wrote down all the
Very good.
steps.
Okay. Now let's go second quit. Run your program again. Run your program. Second quit.
2.
You just click enter.
You can hit enter. You don't even need to go through it again. It'll automatically start.
All I got was 2.
Got 2.
Did I do something wrong?
Nope.
You
Hit enter.
press enter.
I thought-
Whoa! You keep pressing enter, it keeps going.
You press enter again, it'll keep going.
Whoa, look what I'm doing. This is awesome.
Okay.
It keeps going through the numbers that
Again.
it starts.
Again,
Oh, that's the pause.
again, that's your pause. If you look up here, you see this little counter. It says it's paused in the program. It's waiting for your next input. Okay? So on and so forth. So just hit that through until the program ends. Stop there. And it's done. Don't go any further. Okay. So,
Oh, so
let me change this around a little bit. If I were to say, instead of 2 to the x stores y, with your partners, we're going to have the same loop. Don't program this in your calculator yet, but try to figure out what would the calculator do if I did 2x plus 3. What would the calculator present? What would it display out? Take a second, see if you can figure out what it would display out if instead of 2 to the x, we had 2x plus 3. Take,
you want us to actually go change it?
you can edit it if you like, but I would really like to see if you guys get the idea of how this program's
I got
running.
it.
What do you mean?
So if you're not sure, then I want you to write it down.
Mr. Morgan,
Okay.
wouldn't it be like 5 and then 7 and then 9 and then
Yep.
so on and so forth?
Okay. All right.
That's just how to do it.
Now it's linear, so it's increasing as study.
Okay, it's linear, it's increasing at a constant difference. It's not going exponential, but you get the idea. We just go through the process. 1, then we plug in 2, then we plug in 3.
It goes up one every time.
Okay, there we go. Okay, so this is all nice and happy, but what does this do for us? Not much.
I figured out why we have the thing so that you can like put in any equation and it just solves it for you.
Okay,
It just says the same.
Morgan, my calculator is frozen.
guys.
Because mine's stupid.
It's
Okay.
fine.
Nope, it's programmer. All right, so the idea, again, the calculator plugs in 1 for x, throws it through, displays 5. Plugs in 2 for x, runs it through, displays 7.
How come ours?
Wait, why would it display 7?
Guys,
Because
okay. So let's go through this. The first time through, x equals 1, right?
Yeah.
When x equals 1, we get 2 times 1 plus 3. What does that equal? 5. Program gets to the end, comes back up, and says, okay, now I'm going to let x equal 2. 2 times 2, what's that equal? 7.
Did we just create a new program?
Oh, yeah, okay.
You can show me what we did wrong.
Okay. So, Angela, you guys done?
What?
Okay. So, your program keeps cycling through this for each new x. For each new x, we keep cycling through that. This is nice and good, but how can we use this to actually help us out? To actually graph a function. That's where we're going to go next. Okay? Time out. Okay, John.
It can help us find the points of our graph.
Yep, and that's what we're going to do, is we're going to create these points. We may not finish with this today. Brian.
Does the program actually have a function so it'll graph it for you?
Yes. Okay, so here we go. So we're going to add a couple of lines to this. Because what we've just done essentially is that we've just created a graph, created a bunch of points that just basically die. They come out, they say, hey, here's your number, now I'm not going to do anything else. Which isn't very useful. So we need to create something to save it. Do you guys remember lists?
Yeah.
Alright. So what we're going to do is we're going to create some special lists to help hold these numbers. So I'm going to start a new line. Before our entire program, we're going to find 2 lists. The x values and the y values for this function. And we're going to say, I'm going to store take 10, I'm going to define the dimension of some list. I'm going to call int